You've learnt about igneous rocks, you've learnt about sedimentary rocks. The final type of rock in the rock cycle is metamorphic rocks, and what people don't understand is that these guys used to be one type of rock and it's turned into another. And the only thing that you need to remember is that as it's been turned into another, it's gone through a huge amount of heat and pressure, and because of that, this rock has been forced to become harder, stronger, smaller. It's very different than its predecessor. The poor predecessor, imagine it screaming as it was squished over thousands of years, as it's been heated and cooked alive and turned into something completely different than it was before. So here we have precursors or parent rocks which have undergone heat and pressure to literally turn into these rocks. These used to be that. Quite a lot different. The strength properties, they're quite different in hardness and stuff. All of that changes as you heat something up and you give it pressure. And we know that. I mean, if you have, say, a lovely little muffin, and that lovely little muffin gets stuck in the oven, but it gets stuck in the oven a bit too long, it turns into a little yucky looking muffin that isn't quite nice to eat because it tastes a bit charcoaly. Well, if you then squish that muffin, it's certainly not going to taste exactly the same, and it's going to be even harder to chew. And if you then squish it plus cook it, you can imagine how hard it's going to be for your teeth to get through that once lovely muffin when it's been squished and cooked and baked beyond belief. It's now something completely different to what it was before. Essentially, that's what a metamorphic rock is. So those major points that we just did as a recap. Heat and pressure are needed to make metamorphic rocks, but not always both at once. When you just heat something and cook it, it does change it into something new, but it becomes what we call non-foliated if it's just heated. That means the crystals actually start to melt a little, it re-solidifies and grows bigger crystals, but it doesn't have distinct layers in it that we see when we have foliated rock. Foliated rock is rock that has layers in it, and they're very distinct lines and layers, and that tells you that they've also been squished together. So let's go into what are the different types of rock, foliated and non-foliated. Essentially, you have to remember one thing. If it's foliated, it means it was under very high pressure. These guys were screaming as they were squished alive. If it's non-foliated, it was heated, may have been under some pressure, but definitely not high pressures that cause foliation. So they both have a different story. Okay, so non-foliated rock. These are normally ones that are made with a bit of pressure and definitely a lot of cooking. So we often see these along the sides of where volcanoes have pressed through. So this here is what we call an intrusion. It's where magma from below has pushed through the land above, and as it's come out and burst out of this volcano, it's actually cooked the rock as it passes through. The rock where it touched got cooked. So if you had here 3 layers of mudstone, limestone and sandstone, they would have been put down, well, most probably mudstone. Mud tends to get put down in watery environments, most probably from some sort of flood, or the area was actually covered with a swamp or something like that that puts down mud. And limestone and sandstone you usually find when you have oceanic influences, because you have lots of marine organisms with shells and shellfish and skeletons. They dissolve, they fall to the bottom, form limestone, and because it's an ocean, it often will then, well, not often, it always puts sand on top of it, so you end up with this layer of limestone and sandstone together. So that often tells us that an ocean has covered an area when you see those together. Now, as you have the magma push up through here, the mudstone gets cooked into slate, the limestone turns into marble, and the sandstone turns into quartzite. Now, when these do change, you don't see lots of layers of foliation, but you definitely do see an increase in crystal size, and that's because the magma, as it's cooking it, these crystals in these guys actually start to melt a bit, and reorganize themselves and then slowly cool down again, and they grow bigger crystals than were there before. So whatever atoms you have here, they get a chance to recrystallize again in a much larger form. Now this is what we call contact metamorphism, because it's making contact with the rock. And here's an example here. We have limestone here and then marble on top of it, because lava has spread out over the top of this limestone and cooked it and turned the limestone that's between it and the magma into marble. Here's an example of a foliated rock. Notice all the beautiful dark and light lines. That's because the dark minerals are really heavy, the light minerals are much lighter, and when they're put under huge amounts of pressure, they tend to basically group together. So all the heavy minerals will group together, the light minerals will group together, and they form these distinct lines. It only happens under high pressure. Now this was supposed to play for you, but it's not going to. But essentially this shows what happens when we get foliation. This is the crystals that were in the rock beforehand. And what happens, there's the rock there, you can see the dark and light crystals. As you push this down and squish it, the dark and the light crystals have actually banded together to turn into this version of metamorphic rock. Literally that turned into that, okay, simply by realigning the crystals. Now, effects of metamorphism on rock, essentially it makes them an awful lot stronger because it causes them to change chemically and interlock more. That's a big thing. They have larger crystals, they interlock more, so they're stronger, and they often will line up. The crystals will line up if they're foliated, so that also means that they're an awful lot stronger because of that foliation as well. Now the other thing is you can get different minerals growing. So coal looks like this. Same atoms that are in diamond, but look at how the atoms are joined together. A lot more interlinking and bonding here, which makes it a lot stronger as well. So this has literally made what we call a new mineral. Same atoms, but rearranged into a different organization, which makes it something new. Essentially, they're stronger, they're harder, because of the way that their crystals have changed. Now, let's quickly go over what parent rocks here. You must talk about parent rocks as part of your story, because that tells where the rock has come from. You can't just say slate used to be mudstone. Well, before it was mudstone, slate used to be mud. So that actually tells a whole story about what's happened to make this rock. To get mud, you normally have a flooding event, or you have a swamp covering an area. You have something that has covered an area with a very large amount of mud. There's the first part of your story. Then that mud has been squished down and cemented together to form mudstone. There's the next part of your story. But then that rock has been undertaken metamorphism. Now slate doesn't show huge amounts of foliation, but it does have layers in it because mud has layers in it. It doesn't show foliation. It is usually formed from mudstone when it is cooked, and because of that you can assume when you find slate that mudstone has been exposed to a huge amount of heat, which has cooked the stone and turned it into slate. Hey, we have a story. There's a hidden story in the rock. So as soon as you have one hidden story, you can look for others. Think about the hidden stories when you see limestone. What had to happen to form limestone? How did that then turn into marble? An ocean had to have covered an area for limestone to form. Then it had to have been cooked through usually a volcanic event to turn it into marble. There's another story. Same type of stories will happen with other types of rocks. So you must start your discussions with what they came from, what the parent rock was, and what would have happened, whether it was cooked or pressured or both, to turn it into a metamorphic rock. To finish it all off, let's just summarize the sort of change that you'll see in rocks. When you cook and pressure them, you're going to notice a difference in their colour or their luster as they turn into different types of minerals. Foliation, you're definitely going to see that with any that have been subjected to pressure. And you're definitely going to see a difference in the crystal size because the crystals have had a chance to partially remelt and reform into a larger size as long as they haven't been squished to death via foliation. You're also going to see a difference in hardness and strength, and you're going to be testing that in the next few days with our Smashing Rocks experiment.